Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the Sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the Sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the Sun and from space. But even though Saturn is protected by its magnetosphere, the Sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are going to get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf just a fraction the size of our Sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away.
Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out, there are tons of things that can go wrong during a planet's formation, like locking up to the Sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our Sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our Sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the Sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects, like comets and asteroids, in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star, while the other side remains in perpetual darkness. So one side is always very hot, while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation. See this? You're looking at the best full portrait of the Sun by far. Thankfully, our 4.5 billion-year-old parent star didn't use any makeup to fix its skin tone before this photo shoot. And now we can study its surface in great detail. This iconic image was taken in March 2022. NASA wanted to gain a better understanding of solar behavior and its impact on life on Earth, and the future of our space technologies, of course. To do so, they launched the Solar Dynamics Observatory Satellite, or SDO, mission in February 2010. This legendary photo shoot happened 12 years later, when SDO was halfway between the Earth and the Sun. Scientists had to assemble 25 individual images like a puzzle. So the final image contains 83 million pixels. Yeah, the resolution is about 10 times better than your fancy 4K TV screen. Look at this amazing cookie-like pattern. Typically, the bright surface of the Sun overshadows it when we observe the star from Earth. Thankfully, NASA explored the light beyond the visible range, which allowed them to discover some invisible details of the Sun's face. When you adjust your selfie with filters and effects, you can end up with completely different portraits, highlighting different spots of your face, even those you didn't know existed. The same principle works here. All these plasma balls are the same photo of the Sun, captured at different electromagnetic wavelengths. The revealed spots and patterns can help us understand events happening inside the Sun's skin a little better. At the speed of light is supposed to mean super quick. But this rose gold ray caressing your cheek at dawn has come a long way and is incredibly old in human terms. Photons generated by the Sun's core take between 10,000 to 170,000 years to travel through the star's atmosphere, and then around 8 minutes more to reach Earth. So let's explore what's taking them so long. Our tour begins with the upper layer of the Sun's atmosphere. Remember solar deities in movies and theater plays? They often wear luxurious crowns with golden rays. Well, the real Sun does wear a fancy corona too, which is the outer layer of its atmosphere. But of course, its size and glory are incomparable with those plastic costume crowns. And its shape is not so stable. Corona is a gas shell enveloping our parent star, so its size and form constantly fluctuate under the influence of the Sun's magnetic field. You can spot this crown with the naked eye from Earth during total solar eclipses. It looks like a beautiful, intense radiation around the solar disk, which itself is completely blocked by the Moon. The corona stretches 5 million miles above the Sun's surface, whereas our blue planet is only about 8,000 miles in diameter. So, one hypothetical ray of the corona equals a row of about 625,000 Earth-sized planets. And suddenly, all my problems begin to seem tiny. Now here's another fun fact. The Sun's corona kind of breaks the laws of known physics because it's hotter than it should be. Its temperature reaches 2 million degrees Fahrenheit, whereas the surface of the Sun is only about 9,000 degrees. Although the word "only" doesn't fit here, because it's still super warm in human terms. Usually temperature tends to fall as you move farther from a heat source, but it's not the case here. Space scientists are still scratching their heads trying to investigate this mystery. Thankfully, the recent photo shoot allows us to explore what's going on inside this massive hot stuff without risking losing our sight. Take these beautiful bright spots, for example. They depict solar flares happening under the corona layer. Solar flares are powerful explosions that happen when magnetic fields bump into each other. When it happens, they change shape and quickly reorganize. These fields arise from plasma, which is very turbulent itself, so these events are no surprise for the local weather. Now, who would have thought that the Sun has dark spots on its skin, just like people? These darker areas are known as coronal holes. Earthlings can experience their impact when they observe the beautiful aurora lights in the polar regions. Coronal holes look darker because plasma in these spots is cooler, less dense, and magnetically open. These conditions allow the solar winds to escape outward across the solar system rather than hang out at the Sun's surface. And when they bump into the Earth's magnetosphere, auroras emerge to fascinate our eyes. Thankfully, the local fields cool down the solar winds. Nobody wants their eyes to melt, right? Now, if we were looking for an analogy to the Sun's hairs, the best candidate would be solar prominences. These large, bright plasma loops arise from the Sun's surface and stretch for thousands of miles into space. Their lifespan varies from days to several months. It's one of the most common events in this region. Although the first detailed description of solar prominence dates to the 14th century, modern scientists are still researching how and why they're formed. Diving further inwards, we're facing the transition region. The thickness of this layer is about 62 miles, and the local weather is unthinkable. Temperatures can rise up to 900,000 degrees Fahrenheit. The transition layer sits between the corona and the last region of the Sun's atmosphere called the chromosphere. Now, speaking of which, welcome to our next stop. The chromosphere region is famous for a scientific mystery called a spicule. Come on, say it with me. Spicule. That's fun. These spectacular grassy-like jets of plasma fire upwards from the surface of the Sun and reach speeds of approximately 224 miles per second, as if they're jumping on a trampoline from the surface of the Sun. Each spicule lasts for just a few minutes in outer space before falling back into the solar atmosphere. Astronauts were having a challenging time trying to explain how magnetically charged particles could manage to escape the massive gravity of the Sun while being so close to it. The possible answer emerged in 2017. A group of scientists discovered that neutral particles provided the magnetically charged particles with extra buoyancy to escape the solar gravity for a while, which is better than my cousin's explanation, which is happy thoughts and pixie dust. Yeah. Now let's go ahead and travel 1,000 miles inward toward the chromosphere to finally reach the solar surface, the photosphere. It's around 248 miles thick, but unlike planet Earth, the Sun's surface is not solid or stable at all. The temperatures here are insanely hot for any matter to exist. On the other hand, scientists often call plasma the fourth state of matter. And why not? It's made of ionized atoms and free electrons, so it kind of deserves to matter. So what's the matter? Maybe someday we'll happen to meet the local civilization of plasmoid people. But I think it's best that we skip their welcoming warm hugs. You know, hot, hot, hot. Anyway, the photosphere is our final stop, because humankind doesn't have the technology to explore the Sun any deeper. So if you want to learn more, you'll have to invent your own spacecraft. But time's a-wasting. You'll only have about 7 to 8 billion years. After that, our Sun will fade away, according to scientists' estimates. Actually, those same scientists will be going first. Now, you have a serious competitor, though. NASA's Parker Solar Probe is the current champion for the deepest dive into the Sun. The spacecraft managed to travel 4.5 million miles from the Sun's surface toward its core on September 27, 2023. And then, the Parker probe repeated its own record once again in December of the same year. So, why didn't it melt, I hear you asking? The probe has been designed to withstand insanely intense conditions and temperature fluctuations. It's equipped with a custom heat shield and an autonomous system protecting the mission from the massive solar lights. NASA has further ambitious plans. In December 2024, Parker will make its closest approach to the Sun. It will travel faster than any man-made object has ever traveled, at the speed of 435,000 miles per hour. The probe will be just 3.8 million miles away from the Sun's glowing hot surface. It's like landing on a star. Astronomers have already compared this epic upcoming milestone with the moon landing. I'm thinking, however, it might be safer if we, landed at night. Yeah, you're right, that's an old joke. You may not have known this, but the Earth once had rings. Usually Saturn is the planet that comes to mind when we think about rings. However, once upon a time, Earth could have had its own band of dusty particles. It was due to a phenomenon called ring rain, really. Our planet was surrounded by lots of little rocks and dust, perhaps the remnants of a hypothesized ancient planet, Theia. This protoplanet could have existed in the early solar system, and scientists assume that one day it could have collided with the early Earth. In that case, huge remnants of this collision would form our precious moon, and smaller rocks would result in the rings. In any case, the particles were pulled toward Earth's surface by gravity. All this happened around 4.5 billion years ago, shortly after Earth's formation. We know about them thanks to various sources. For example, we found some tiny glass beads in ancient rocks, which might have formed due to intense heat during ring particles' entry into Earth's atmosphere. We also found things like traces of isotopes in ancient rocks. Now, these rings would be much smaller than Saturn's though, and weren't icy like Saturn's, so they weren't glowing. Our rings were mostly made of rock and dust. Scientists believe that they started around 620 miles above sea level, extending to the Roche limit. They'd be farther away from Earth than our International Space Station and most satellites. From the equator, the rings look like a straight line across the sky, but if you move north or south, they widen, creating a celestial arc. Near the North Pole, they would gain a subtle twilight effect. But unlike Saturn's rings that endure, Earth's were fleeting. Blame the Sun! Earth's proximity caused water ice particles, potential ring makers, to turn into gas, leaving no bling behind. Ultraviolet light from the Sun stripped away the rest. But what if Earth kept those rings? Imagine seeing this celestial spectacle day and night. Visually, it would be stunning, floating elegantly above our planet. During the day, we'd be adorned with their shimmer, and at night, they would be so bright and mesmerizing that they would even outshine the full moon. However, their impact on our lives wouldn't be that cool. First of all, the luminosity reflected off the rings might confuse nocturnal creatures, like dung beetles or swallow-tailed gulls. They're guided by the starlight, so poor creatures would be very confused by all this extra glow. This would disrupt their natural behaviors. The shadow cast by the rings could mess with our weather patterns as well. It would affect sunlight levels and pose a challenge for photosynthesis. Temperatures on the planet would change depending on the thickness and composition of the rings. They would impact our seasons and, potentially, cause even cooler winters and hotter summers. Satellites in Earth orbit might have faced some chaos as well. Space rocks hurtling at them could spell trouble for our high-tech companions. Perhaps things would be better if we kept them initially and evolved with them already existing, adapted to them. But if they suddenly appeared right now, it would cause tons of problems. Well, good thing that only Saturn has rings now. Or maybe not only Saturn. Its glowing bands and the famous Cassini division are visible even through a small telescope or binoculars of an amateur astronomer. They're super old and might have formed back at the times when dinosaurs roamed Earth. But, in reality, all 4 giant planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, have them. Their stunning sets of rings are composed of tons of tiny dust particles, a mix of rocks and ice, ranging from tiny bits to sizes as big as a house. It varies from planet to planet, and each of them has its own material makeup. To find out more about this makeup, we can simply look at them. Some particles are as tiny as sand grains, while others are as big as double-decker buses. We also look at how reflective they are and how much they sparkle. Saturn's rings, for example, are mostly water ice, and they look like sparkly frozen droplets. Jupiter's rings, however, are more dusty with fine rocky particles, similar to asteroids. Uranus keeps its ring material a secret, but it's dark and not so sparkly, hinting it's not water ice. Instead, it could be carbon or carbon-containing dust, maybe even charcoal. And Neptune takes it up a notch. Its rings are even darker, suggesting superfine dust, maybe carbon or methane ice. Scientists also study what sort of light these particles emit. They split this light into a spectra and look at the ring's secrets. For example, water ice, iron, and organic tholins are given the rings a reddish tint. And these giants are not the only ones in the universe who have this cool feature. For example, there's a planet way beyond our solar system called J1407b. It has rings 200 times wider than Saturn's, and it looks insane. The planet was called Super Saturn by NASA. On the other end, there's an object with only 2 tiny rings called 10,199 Car-Iklo. If the Super Saturn is most likely a giant with huge gravity, then this thing is very tiny. It's not even a planet. It's the so-called Centaur, which is what we call small celestial bodies. In the case of faraway planets, usually we find their rings thanks to radio waves. All planets or satellites send out radio signals. When these signals pass through the rings around them, it results in a weird and pretty crazy symphony. The size and weight of particles in the rings decide the notes. For example, lighter particles, like aluminum, have their own groove, which is different from iron's. Now, the true mystery is how they're formed at all. Each of the planets in our solar system has its own ring history. In Saturn's case, scientists thought that maybe it had some huge moon, and then this moon broke apart for some reason, after a collision, for example, resulting in fascinating rocky bands. But if we sum up all the rocks, they don't result in a big enough object, so that theory most likely isn't true. They might have appeared because of the collision, but between some other objects. Jupiter's faint rings come from dust particles flung into orbit by micrometeorites. Neptune has not really rings, but rather arcs. They're not complete circles around a planet, but just parts of the circle. They're influenced by the gravitational pull of the moon Galatea. And finally, Uranus's mysterious rings, like red and blue ones, puzzle scientists. We have no idea where they came from. Same with Super Saturn and a centaur we mentioned before. The rings in our solar system have their own future. The sad truth is that Saturn will lose its iconic rings one day. NASA's Cassini spacecraft showed that they're slowly being pulled into the planet by gravity and magnetic fields. It happened so fast that Saturn's ring rain could fill an Olympic-sized swimming pool every half hour. So one day, what was once a spectacular sight stretching 22 times the length of Earth will shrink to almost nothing, becoming just a tiny part of Saturn. But hey, don't worry, despite the speed, it will take about 1 to 300 million years for all the rings to fully vanish. But there's an upside. Mars might gain its own rings one day, although it will take a long time too. In the next 30 to 50 million years, Mars could witness its moon Phobos breaking apart and forming a dazzling band around the planet. The pieces that don't contribute to the ring will create craters on the Martian surface, so let's hope we won't live on this planet by that time. Scientists in NASA hope to study the rings of different planets better in the future. In the meantime, the James Webb Space Telescope will keep scanning and analyzing them. Let's hope that we'll learn more about their mysteries and our solar system's history. Now, I don't want to spook you, but there's a chance that our entire Milky Way galaxy is located in the so-called space void. It's a region where there's relatively little matter compared to other corners of the known universe, and it's much less dense than it is elsewhere in the universe. In other words, we might exist in an air bubble in a cake. If that's true, it would mean that we're even lonelier than we thought. In our universe, all the galaxies are constantly moving away from each other. In order to understand how far they move away, scientists use something called the Hubble-Lemaitre constant. It's like a speedometer, but for galaxies. However, there's a cosmic mystery called the Hubble tension. It's challenging what we know about the universe's expansion. Scientists used to consider the Hubble-Lemaitre constant a reliable guide, but our recent observations question this reliability. The speeds we see in real life don't match up with the distances we calculated and expected. They aren't sure why these measurements don't add up. Researchers followed the moves of supernovas and saw that the universe seems to expand faster around us than it does overall, as if it's actively avoiding us specifically. After considering this, they began to assume that we might all live in a cosmic void. Cosmic voids are vast, empty spaces between galaxies, kind of like between my ears. They make our entire world look like a big sponge. Now, let's go back to the beginning, just a fraction of a second after the Big Bang. Right after the beginning of everything, the universe was a hot, compressed plasma. It only had very tiny variations in density, called quantum fluctuations. After the Big Bang, the universe began to expand. Those quantum fluctuations grew together with it, creating regions of varying matter density. Because of that, the universe didn't expand everywhere uniformly. Instead, little claps of matter began to gather together over a long period of time, creating massive structures, galaxies. Galaxies are arranged in huge walls and filaments, with enormous gaps in between. And these gaps are voids, also known as dark space. Now, these voids aren't truly empty. In fact, they actually hold more than 15% of the amount of matter found on average throughout the entire universe. They still contain gas, dust, dark matter, and even stars and galaxies. However, they have less density than regions with galaxies, about a tenth of the average matter density, which is why we consider them nearly empty. Usually, they'll have a diameter ranging from about 30 to 300 million light-years. That is an enormous distance, even on a space scale. For comparison, most planets and nebulas we've found so far have a distance of hundreds and rarely thousands of light-years away from us. In the case of voids, if you were in the middle of one, it would just look like seemingly eternal darkness. The closest stars would be so far away that they would be almost invisible to you. Some of them are especially large. They're known as supervoids. The largest known one was creatively named Giant Void. Ooh. It's so big, it's impossible for us to even imagine. 1.5 billion light-years away, with a diameter of 1 to 1.3 billion light-years. Yeah, it's basically a big dark vacuum. But even this giant vacuum isn't entirely empty. The Giant Void houses 17 separate galaxy clusters within its expanse. However, it might not be the biggest emptiness in our universe. There's this thing called the CMB cold spot. It's this unusually large and chilly area of our universe that we saw through the microwaves. It really stood out on the map of our universe with its unexpectedly low temperatures, and scientists have spent many years trying to figure out what the thing is. In 2015, scientists proposed that this place might be a supervoid, and probably the largest one ever. Being even more original with this one, they called it the Great Void. If it's true, this place would be an emptiness of about 1.8 billion light-years in diameter, about 1,000 times larger than typical voids. Not everyone thinks that's possible, so scientists keep arguing over this one. There's another interesting theory going about this place. One researcher suggested that this place might have been a trace on our collision with a parallel world. It's a pretty bold hypothesis, but unfortunately, there's no way for us to confirm or deny it with our current technologies. In any case, as the universe expands, these voids will grow, and the walls connecting galaxy clusters will stretch and break. Eventually, the voids will merge, leaving gravitationally bound galaxy clusters as islands in the expanding emptiness. In other words, sooner or later, the great emptiness will consume everything in our world. So, it turns out we might be a rare occasion in a supervoid, one of the 15% of matter. This would explain why we're surrounded by relatively few galaxies. This discovery, if true, challenges the standard model of cosmology, which we created with Albert Einstein's help. It would mean that gravity in general behaves differently than what we expected. According to the standard model, such a significant underdensity shouldn't exist. Because of that, scientists will have to explore and consider this idea thoroughly. It might just challenge our very basic understanding of physics. The scientists call this the local hole. The discovery of the local hole may hold clues to explaining the Fermi paradox. Maybe in this specific part of the universe, where we hang out, the chance of intelligent life developing anywhere nearby is very low. Perhaps all of the sentient beings hang out somewhere beyond our supervoid. But that doesn't mean we should lose hope, or that life anywhere nearby is impossible. In fact, life in the universe might be much more common than we previously thought. We know that the inner planets, like Mercury and Venus, are inhospitable due to extreme conditions. However, Venus looks interesting because even though it's a crazy toxic planet, scientists believe that it was very Earth-like in the past. It could have even hosted life. Unfortunately, it was too close to the Sun, and all the nice conditions evaporated over time. But there's a possibility of microbial life surviving in its high-altitude clouds. Mars, a cold desert, also might have been a friendlier place in the past with rivers and lakes. Though now it lacks a protective atmosphere, ancient life might have existed there. In that case, it would leave potential fossils, and underground microbes could still survive. We've discovered some signs of them, but are still debating whether this stuff was truly organic or not. The gas giants, like Jupiter and Saturn, and ice giants are not ideal for life, but their moons offer hope. Europa has an ocean beneath its icy surface, making it a potential hotspot. Enceladus releases water into space, carrying complex molecules that hint at interesting possibilities. And Titan is especially unique. It has liquid bodies on its surface, rivers and lakes of hydrocarbons. While its frigid temperatures aren't great for life, scientists ponder if it might host life with a different kind of chemistry. However, it will take us decades to check all these celestial bodies and study them properly. We haven't sent anything so far since the times of Voyager 2, but if we're lucky, we might explore our solar system during the 21st century. In any case, there's a lot of potential for life even in our solar system alone, not even mentioning all the planets and galaxies we found nearby. Our estimates suggest that the observable universe, the one we can see, might host around 5.3 trillion habitable worlds. One of the most likely candidates so far is Kepler 186f. It's a potential Earth-like planet, just 10% larger than Earth. This planet orbits a red dwarf star, which is a star a bit dimmer, colder, but more long-living than our Sun. And it's only about 490 light-years away, which may sound like a lot, but remember what distances we've discussed with supervoids. So even if we really are in a supervoid, we're still lucky to have many galaxies and planets around. And if one day we'll find a way to travel through the universe, leaving the local hole probably wouldn't be a problem. Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons. standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
The soil beneath your feet is red and dry. The place is freezing cold. Rusty-colored dust is floating in the air. You make one step, then another. It's hard to move because of the thick layer of dust your feet are sinking into. You're on Mars, and you've come here after hearing some absolutely incredible news. These days, the so-called red planet indeed looks dry and dusty. But scientists think that this world might have been very different a long, long time ago. They have found some evidence of a huge ocean that could have existed on the surface of Mars about 3.5 billion years ago. And this ocean probably covered hundreds of thousands of square miles. It all started with numerous satellite images of the surface of the red planet. They were snapped at different angles. As a result, researchers managed to construct a relief map of the area. They charted out more than 4,000 miles of specific formations that had most likely been carved by rivers. Those formations could also be channels, once carved out on the sea floor. Scientists used the data gathered by the Mars Reconnaissance Orbiter in 2007. They analyzed the thickness of the ridges and their angles and locations. Their main goal was to explore the topographical depression called Aeolus Dorsa. It turned out that all those years ago, this part of the red planet had been undergoing a series of constant changes. They could have been caused by the rapid movement of rocks, pulled around by currents and rivers, as well as noticeable increases in sea level. Researchers also noticed a pretty clear boundary that separated the southern highlands of Mars, elevated and highly cratered, from the smooth lowlands of the planet. It looked very similar to a shoreline left by a ginormous ocean. This all likely means that in ancient times, there indeed was an ocean on the surface of Mars, and a large one at that. What's even more exciting is that the existence of such an ocean might mean the existence of life. This discovery can tell scientists a lot about the ancient climate on the red planet, as well as its evolution. We now know there had to be a period on Mars when the planet was quite warm, and its atmosphere was thick enough to keep so much liquid water. What's even more incredible, the climate in the northern hemisphere of Mars 3 billion years ago could have resembled the one we have on Earth nowadays. But then, where is this ocean now? What happened to it? Perhaps the climate of the red planet was becoming cooler, and the surface of the ocean froze. There's a theory claiming that these days, the ocean remains in its frozen state deep under a layer of rock, debris, and dust under a northern plain called Vasticus Borealis. Or the ocean's waters could have been lost to the atmosphere, and eventually space through the process of atmospheric sputtering. During this process, atoms get knocked away from the atmosphere after colliding with high-energy particles coming from the sun. Anyway, the theory of an ocean that once covered a substantial part of Mars's northern hemisphere hasn't been confirmed yet. Scientists are still arguing about its existence. As for now, Mars is a very cold world with an average temperature of -80 degrees Fahrenheit. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The ocean that might have existed on Mars isn't the only awesome thing about this planet. Let's speak about those sandstorms raging on the red planet. In movies, they're depicted as incredibly powerful forces of nature, destroying astronauts' camps and tearing their spaceships into pieces. But how much of it is true? Mars is indeed infamous for producing dust storms so massive they can be seen by telescopes on Earth. They sometimes cover continent-sized areas and can last for weeks at a time. But besides them, there are much rarer storms that occur once in 3 Mars years, which is about 5.5 Earth years. Such storms are larger and much more intense than regular ones. They encircle the entire planet. That's why scientists call them global dust storms. At the same time, It's unlikely that even a global dust storm could cause serious harm to astronauts or their equipment. Even though Martian storms are massive, the wind speed reaches 60 miles per hour tops. That's less than half the speed of most hurricane-force winds on Earth. Plus, this comparison of wind speeds can be kind of misleading. The atmosphere on Mars is just 1% or so as dense as the atmosphere on our planet. It means that the wind there needs to blow much faster to cause any damage, or even fly a kite. Now let's move to the next amazing phenomenon spotted on the red planet. When you look at it from a distance, it looks like an eye. There are even some winding channels that look like veins running through the eyeball. But the closer you get, the less the formation looks like an actual eye. It's actually a giant crater, almost 19 miles in diameter. Around the crater, which looks as if it has a pupil, there are other, even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once, water filled the ginormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Your next destination is Valles Marineris. That's an enormous canyon, or rather, a canyon system that runs along Mars's equator. It stretches for more than 2,500 miles. It's also 4 times as deep as the famous Grand Canyon on Earth. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Most scientists think that Valles Marineris is a huge tectonic crack in the crust of the red planet. It could have formed when the planet was cooling down in the distant past. Another breathtaking sight on Mars is the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which means it's almost the same size as the state of Arizona. The mountain is also 16 miles high and rimmed by incredibly tall cliffs. To imagine the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, around 2.6 miles high and 75 miles across, which actually sounds pretty impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. Scientists have been wondering for quite some time why this volcano is so large. It might be the result of lower surface gravity and higher eruption rates. Or the reason may be the red planet's crust, which is very different from Earth's. On our planet, the crust is made up of 15 to 20 moving tectonic plates. As plates move over hotspots that produce lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. Now, if you visited Mars and decided to go on an evening stroll, you'd witness a strange phenomenon. It occurs on the red planet after sunset, when temperatures fall below -80 degrees Fahrenheit. A bizarre, mysterious glow spreads across the Martian sky. Unfortunately, without special equipment, you wouldn't be able to observe this soft glow. Visible only in ultraviolet light, this night glow is the result of chemical reactions that occur dozens of miles above the surface of the red planet.